An often asked question when meeting new scientists is, wet lab or dry lab? This is the wet lab. I am a wet lab person. I work down here with wet things, with liquids, with pipettes. I do the things with the liquids. Dry lab refers to computational biology, doing a lot of analysis and coding and writing tools and all kinds of cool stuff. When I came into grad school, I was 100% wet lab and had zero interest in looking at dry lab stuff. But I had to. As part of my program, I had to learn how to program and learn how to code, and honestly, it made sense. I had to learn how to analyze my own data that I was generating in the wet lab. And I've really come to admire bioinformatics and dry lab work. I think that it can be really beautiful, clean, wonderful biology and science, and I think it's super cool. But I am still a wet lab biologist at heart. Here in the lab is where I feel comfortable. This is where I do my work. But I think it's becoming a lot harder to just be a wet lab biologist. Now, this is definitely skewed by my field. I'm in genetics. I think this is definitely a trend in my field. But what I see at the moment is that if I want to be able to analyze my own data, I really need to build those computational skills. From what I see around me in my field and in my department, I think you can definitely be just a dry lab scientist and never come down here and touch a pipette. But I think it's becoming harder and harder to be just a wet lab biologist. Especially for me, I do a lot of sequencing, and if I want to be able to analyze my sequencing data, I have to be able to understand and run the code that does that myself. I don't want to just hand it off to somebody else and say, I did an experiment, analyze it, and find out what it says. I want to and need to be able to do that myself. So I think that being just a wet lab biologist, I might be one of the last generations of scientists, or at least geneticists, who can kind of claim to be just a wet lab scientist, because that's becoming less and less true for me, and I think that for people coming into the field, it's becoming far less true. You really need to be able to do both, or at least dabble in both, as a wet lab person. So what this means is that I'm learning to code. I had to take a crazily scary, intense coding course my first year here that was dealing with genetics data. And for the people who already knew how to analyze this stuff, I think it was super easy. But for me, it was taking me 30 to 40 hours a week just to do the problem sets, because I'd never done any kind of coding before. And before the class, I'd worked my way through the Codecademy Python thing, and then I was learning Python in the course, and now I really like it. I don't spend very much time on it. Really, I am focused down here with the experiments and the pipettes, but when I do get the chance to work in coding and in doing this sort of analysis, I think it's really interesting, and it's very satisfying when you want to build or write a script or a tool that does something. Once you finally get it to the point where it does that something, that is such a satisfying feeling, and I like that feedback from coding. But I think you can probably tell that I'm like not a dry lab person by the fact that I keep calling it coding. I don't like, I feel like that's the wrong term. I feel like I should be doing, software development or tool writing or scripting or something, but I don't know what I'm doing. I'm just writing things in Python. And I get a lot of emails and comments and messages from people who are programmers and developers who are watching my videos and they want to help out, and so they're offering to build me tools that I need if they don't exist, and offering to help. And while I love that enthusiasm and excitement, that's my job. If there is a tool that I need that doesn't exist, it's my job to write it. That is now part of my title as scientist, is to be creating the tools that I need. And so I'm doing that right now in a project. I have a kind of weird data set. It's a little unusual, and I need to do a type of analysis to it. And I looked around, and there is not a tool that does the analysis I want on the data that I have. So I'm writing it. Am I great at coding and scripting this tool? No, it is slow, and it is certainly not the most efficient code I could be writing, and currently it only does like 90% of the things that I want it to do. But I'm doing it, and it's starting to work, and I'm making progress, and I'm learning. And that's what I'm here to do in grad school, is to learn new things. Even if they are things that when I came into grad school, I threw up my hands and said, nope, do not want to touch that. I am a slow coder who only knows Python and asks a ridiculous amount of questions, but I'm doing it, and I'm getting it done, and I'm kind of a little bit proud of that. Go forth and do wet and dry science.
Cerebellum. This little gray thing here is your hippocampus.
Oh, okay.
And then this is like the brainstem, so like pons, medulla, corpus callosum,